Based on the transfer function in S domain for Chebyshev filter that we have determined in the previous slide, we need to determine the pole, all the four poles from the denominator of the transfer function. Since this is fourth order equation, so this will be a long calculation. So first we let the u equal to s squared, so we substitute u, so this one become u squared, so this one becomes u, and we have this one. So this is the new equation after we change the parameter u equal to s squared. So we have this function, this factorization function, after using the calculator. So we have this first pole and second pole, and then after that we plug in again u equal to s squared in this equation. The next one, so this is the first root of the Chebyshev filter. So we rearrange again these two factorization equation. So this is root number 1 and this is root number 2. So we have this one and also this one. The next one, okay, we determine the magnitude of this function, the s squared magnitude. We change these complex values into the polar form, so we take the magnitude only. For the s squared function, for both root number 1 and root number 2 will have the same magnitude, where this magnitude is actually equal to set a squared plus b squared set. So this is actually equal to this one, a squared plus b squared. So this is the first equation. In this case, since our roots are complex roots, so we have our roots, which is pole in this case, is equal to a plus jb. This is the real coordinate and this is the imaginary coordinate. When we calculate and determine the squared complex root, we have a plus jb squared, which is equal to a squared plus 2jab minus b squared. So when we rearrange, this is the real part, a squared minus b squared plus 2jab, this is the imaginary part. The next one, for first root, okay, so based on the equation of magnitude for s squared, so we have a squared plus b squared. Based on the equation number 1, this is applicable for both root number 1 and root number 2. The magnitude is 0.2205. And then based on the s squared function for complex values, we have a squared minus b squared for real part plus 2jab for imaginary part, where for root 1 we have this root, we have these complex values. And then equalize to this equation, so we have real part a squared minus b squared equal to this value, and also for imaginary part we have 2ab equal to this value. So this is equation number 2 and this is equation number 3. And now we add equation number 1 and number 2. Okay, this is equation number 1 and this is equation number 2. So we add equation number 1 and number 2. We add this one and this one, so we have 2a squared, while for b, there's no b anymore because b squared minus b squared is equal to 0. So we add these two values. So we have this value for 2a squared, then we can determine a squared equal to this value, and finally we can determine the value of a, the real part, which is plus minus 0.108. So from equation number 1, since we know that a squared is this value, so now we can use this first equation to determine b squared, and we can determine b, which is equal to plus minus 0.457. And then to determine the pole of the system based on root number 1, we use equation number 3, where if we use A with the positive value, therefore B must be positive value based on this equation, since this is positive. And if we choose A which is the negative value, meaning that B also need to has negative value based on the third equation. Therefore, our pole based on root number 1, we have two poles, is this one in terms of polynomial factorization. So this is root number 1.